Plate tectonics. Objective: to learn the theory of plate tectonics and the different types of plate movements. Plate tectonics is a theory used to explain the movements of Earth's lithosphere. Scientists and geologists have found evidence supporting the theory of plate tectonics. Studies indicate that at one time, all of the continents on Earth were bound together as a huge landmass that has been named Pangaea. Gradually, the continents began breaking apart and separating during a process known as continental drift. The theory of continental drift was subsumed by the theory of plate tectonics, which supports the shapes of the present-day continents. Let's take a closer look into the theory of plate tectonics. If we were to look at a cutaway of Earth, we would see very distinct layers. The outermost layer is the crust. Below that sits the mantle. Together, the crust and the upper layer of the mantle form a region known as the lithosphere. The lithosphere is not a solid, continuous layer. Instead, it is made of many large slab-like pieces called tectonic plates. The plates of the lithosphere are constantly moving. The theory of plate tectonics suggests that the Earth's surface is made up of 7 or 8 major plates and several minor plates. The plates can move toward each other, they can move away from each other, or they can move past one another. The interaction of the plates causes one of 3 types of plate boundaries: convergent, divergent, and transform plate boundaries. Convergent boundaries are formed in places where 2 of the tectonic plates collide. Plate collisions can result in the formation of trenches, mountains, volcanoes, and earthquakes. Divergent boundaries occur in areas where 2 plates have moved away from one another. As 2 oceanic plates move apart, hot magma from underneath will flow up and form volcanoes. Transform boundaries occur in areas where 2 plates have moved sideways past each other. As 2 plates slide past each other, the crust will break and form a fault line. Usually, earthquakes will occur along these fault lines. It is this movement of the Earth's tectonic plates that is responsible for the various landscape features we see across our planet. Summary: the theory of plate tectonics is used to explain the movements of Earth's lithosphere. The plates can move toward each other and collide, move away from each other, or move past one another. Earthquakes, volcanoes, mountains, trenches, and faults are formed due to the movement of tectonic plates. Plate boundaries, convergent boundaries. Objective: to learn about the formation and types of plate boundaries with an emphasis on convergent boundaries. Our Earth is composed of 4 layers: the outermost region, which is the crust, the middle region, which is the mantle, and at the center, the inner and outer core. Together, the crust and the outermost region of the mantle form the lithosphere, a region made up of broken pieces and plates. We refer to these plates as tectonic plates, and they float on the viscous mantle. The interactions between these plates will create one of 3 plate boundaries: convergent, divergent, or transform. In this session, let's take a look at how convergent boundaries form, as well as what results from their formations. Convergent boundaries are formed in places where 2 of the tectonic plates collide. These collisions can occur between a continental plate and an oceanic plate, between 2 continental plates, or between 2 oceanic plates. When an oceanic plate collides with the less dense continental plate, the oceanic plate will sink beneath the continent, forcing the continental plate upward. During this type of interaction, the subducted plate, meaning the lower plate, will melt into the mantle. This boundary will create a volcanic mountain range near the coast. The Andes Mountains in South America were formed due to this convergence between continental and oceanic plates. Oceanic and continental plate collisions also result in earthquakes and long, narrow topographic depressions on the sea floor called trenches. When two continental plates collide, neither plate will subduct beneath the other. Because there is no subduction, the plates will have nowhere to go but up. This collision will result in the formation of large mountains and earthquakes at the convergent boundary. The Himalayas, a mountain range found in South Asia, is the result of one of these continent-to-continent collisions. When two oceanic plates collide, the older plate, which is also a denser plate, will subduct beneath the younger plate and melt into the mantle. The molten magma will rise up and erupt. This type of collision will create an island arc, a line of volcanoes in the ocean. The Philippine Islands near Japan are due to the collision of oceanic plates. When two oceanic plates collide, it also creates ocean trenches and earthquakes. Summary: plate boundaries are formed in places where two tectonic plates interact. The interactions between tectonic plates create convergent, divergent, or transform plate boundaries. Convergent plate boundaries occur due to the collisions between a continental plate and an oceanic plate, between two continental plates, or between two oceanic plates. Plate boundaries, divergent and transform boundaries. Objective: to learn about the formation and types of plate boundaries, with an emphasis on divergent and transform boundaries. Our Earth is composed of 4 layers: the outermost region, which is the crust, the middle region, which is the mantle, and at the center, the inner and outer core. The crust and the outermost region of the mantle together form the lithosphere, which is divided into plates called the tectonic plates. The tectonic plates float on the viscous mantle. The interaction of the plates causes one of 3 types of plate boundaries: convergent, divergent, and transform plate boundaries. Divergent boundaries occur in areas where 2 plates have moved away from one another, and they can be found on land or deep under the oceans. When these 2 continental plates move away from one another, a rift valley will form. As the 2 plates move apart, hot magma from underneath will flow up and form volcanoes. One of the largest of these rifts, the Eastern African Rift, runs from Jordan to Mozambique. If the continental plates continue moving away from one another, the rift valley will expand, eventually forming an ocean. Scientists believe this is how the Atlantic Ocean was formed when the continental plates diverged. Divergent boundaries can also be found beneath the oceans, where they will form mid-ocean ridges. As ocean plates move apart, magma from the mantle will rise up and cool. This movement will push the original seafloor outward, and new oceanic crust will form as ridges. The Mid-Atlantic Ridge, which runs from the Arctic Ocean down around the southern tip of Africa, is an example of one of these boundaries. Transform boundaries occur in areas where 2 plates have moved sideways past each other. With these boundaries, the crust is neither created nor destroyed. During this type of interaction, 2 plates can slide past one another in the same direction or in opposite directions. As 2 plates slide past each other, the crust will break and form a fault line. Usually, earthquakes will occur along these fault lines. The San Andreas Fault in California is a transform plate boundary. At this boundary, the Pacific and North American plates slide past each other in the opposite directions. Due to the friction of the opposite moving plates, this area experiences many earthquakes. Summary: the interactions between tectonic plates will result in convergent, divergent, and transform plate boundaries. Divergent plate boundaries occur when two plates move away from one another. Transform plate boundaries occur when two plates slide past one another in the same direction or in opposite directions.
Movement of the Earth. Objective: to learn how the Earth moves around itself and around the Sun. We live on the planet called the Earth. Our Earth is round like a sphere and is covered with land and water. The Earth keeps moving all the time. It has two different types of movement, rotation and revolution. Let's look at a spinning top. It is moving round and round on its point without changing its position. This spinning is called rotation. Our Earth also spins around itself on an imaginary line that passes through its center. The imaginary line is called the axis. Our Earth rotates from left to right. So we can say that rotation is the spinning of the Earth on its axis. Rotation of the Earth causes day and night. One half of the Earth that faces the Sun will get bright sunlight, and it is called a day. The other half will not get sunlight and will be dark. It is called night. Our Earth takes 24 hours, or 1 day, to complete one rotation. The Earth keeps rotating and also moves around the Sun in an imaginary path called an orbit. The movement of Earth in an orbit around the Sun is called revolution. Our Earth takes 365 days, or 1 year, to complete one revolution. The revolution of the Earth causes seasons like summer, winter, autumn, and spring. Summary: rotation is the spinning of Earth on its axis. Revolution is the movement of Earth in an orbit around the Sun. Rotation causes day and night. Revolution causes seasons.